5.5, we're performing function operations. So operations of functions, you have learned how to add, subtract, multiply, and divide polynomial expressions. These operations can also be defined for functions. So operations on functions, we're going to let f and g be any two functions, and then a new function can be defined by performing any of the four basic operations on f and g. So let's look at the operation addition. And we're given the example f of x equals 5x and g of x equals x plus 2. So the definition of adding, what it looks like is you would see f plus g of x. Okay, so you'll see something like that. And all that means is you're going to take f of x and add it to g of x. So let's do that to f plus g of x. And so we're just going to take these two functions and add them together. 5x plus x plus 2. So we get 5x plus x is 6x plus 2. Subtraction. So f minus g of x, all you're going to do is subtract the functions f of x minus g of x. So f minus g of x equals 5x minus x plus 2. And then, of course, you distribute the negative. So 5x minus x minus 2. This becomes 4x minus 2. Multiplication. So you would see f times g of x. And so you're just taking f of x and multiplying it to g of x. So let's try it out. F of g of x. We're going to multiply the two functions together. 5x times x plus 2. So you distribute, you get 5x squared plus 10x. Division. So this is f of g of x. And so you have f of x over g of x. So if we try it out with this one, f of g of x, we're going to take 5x over x plus 2. And we can't simplify further than that. So the domains of the sum, difference, product, and quotient functions consists of the x values that are in the domains of both f and g. Additionally, the domain of the quotient does not include x values for which g of x equals 0. So looking at this example here, just to kind of look at that right now, what can the denominator not be? So we cannot have 0, so you can always do zero product property. Well, I think of zero product property for solving for it. You just set it equal to 0, and you subtract 2 from both sides, so x cannot equal 2, right? Because that makes the denominator 0. So it's all real numbers except x cannot equal 2. So let's just practice more of these, adding two functions together. So let f of x equals 3 root x and g of x equals negative 10 root x. We're going to find f plus g of x and state the domain. Then we're going to evaluate the sum when x equals 4. So we're just looking at the domain. We're not looking at range. So let's first rewrite it. f of x plus g of x is going to be 3 root x and then plus a negative 10 root x. You just subtract 3 minus 10 is negative 7 root x. So then our domain, so the domain for this is x has to be greater than or equal to 0. We can't have anything less than 0. We can't have any negatives in our square root. It's an even root. The next thing is we need to evaluate when the sum is x equals 4. So we'll plug in 4. So this is negative 7 times 2. So the answer is negative 14. Try out this next example. Pause the video. Okay, so let's add these functions together. We're going to do f of x plus g of x. So this is negative 2x to the 2/3 plus 7x to the 2/3. So negative 2 plus 7, that gives us a negative 5x to the 2/3. Maybe we should try to rewrite it so we can kind of take a look at this. This is negative 5 cube root of x squared. So our domain in this case, looking at it, because we have a cube root, is all real numbers. We have no restrictions at all. Then we're supposed to plug in 8 to see what we're supposed to evaluate when f plus g equals 8. So negative 5 cube root of 8 squared. So negative 5 times 2 squared is negative 5 times 4, or negative 20.